this is your host, Dante Aerophisia. This is the first video in a planned series discussing the nature of gender and sexuality. This episode, as the title implies, will focus on how hypergamy, that is, mating exclusively with those above your own social tier, is intrinsic to femininity, but not masculinity. Let's start by asking a fundamental question. That is, what is the difference between a male and a female in any species? If we encountered aliens in the future and we observed that their bodies took two forms, how would we identify males versus females? What it comes down to is gametes. The simple answer is that those with smaller gametes would be considered male, whilst those with bigger gametes would be considered female. This very simple physical difference has a profound implication for behavioral differences. In Richard Dawkins' book, The Selfish Gene, he proposes a hypothetical origin story for gender. I mean, why have gender at all? The following example is derived from this hypothesis. Imagine a species of single-celled organisms. The way this species reproduces is that adult cells fuse to form a larger parental cell. This parental cell then buds off to form a series of baby cells, and the parental cell subsequently dies. And that's an assumption we make for simplicity's sake. Let's say that eventually one of these babies has a mutation that causes it to grow to a larger size as an adult before reproducing. So these new jumbo cells, in turn, form larger parent cells when they fuse with other adults. In turn, they may be able to produce more baby cells. Their baby cells may be larger and thus better adept to the environment, better able to defend themselves, better able to acquire resources, and as a result, natural selection favors this line of cells, and we begin to observe that these cells take over the population. This can continue in a positive feedback loop in which subsequent generations become increasingly larger to take complete advantage over being a larger size. However, there may be evolutionary constraints imposed by the fact that being a large size impedes movement. And larger cells have a harder time moving around, therefore they have a harder time eating, they have a harder time encountering mates, and therefore we observe an evolutionary constraint. That is to say, the cells will just reach a point where they stop growing. Now let's say that eventually one of these baby cells acquires a mutation that inhibits growth. Instead of growing, this baby cell goes ahead and decides to mate with an adult cell right off the bat. Now the baby cell can get away with doing this because the species has evolved to become so large that it no longer needs to have its own reserve of mass in order to propagate the next generation. And so, in the offspring, we observe that some of the cells hold the gene to become, jumbo in size, and some of them hold the gene to remain small. The advantage of a large size remains the same, however, now the baby cells that remain small have the advantage of being able to reproduce quickly. Also, you can produce a lot of them at a much faster rate than you'd be able to produce the larger cells. In this situation, the larger cells still prefer to mate with other large cells. However, as the smaller cells begin to propagate rapidly and take advantage of the larger cells, the larger cells will now be inclined to evolve even larger to compensate for the deficits of mass provided by the smaller cells. As a result, they lose their mobility, and it becomes increasingly difficult to find other large cells to reproduce with. And so these larger cells may try to develop mechanisms to discriminate against smaller cells. However, the smaller cells in turn may develop mechanisms of bypassing the larger cells' defenses. At this point, these cells can philosophically be described as being male and female. Males are unable to reproduce with one another, though females are. So given that females aren't going to be able to encounter other females, they may now develop mechanisms of discriminating against other males. And therefore, we may begin to see the female cells picking male cells that have certain characteristics, such as maybe they pick male cells that provide some level of defense for them. Maybe they pick male cells that bring them food to eat, or other resources. So you may be wondering how looks hypergamy comes into this. Well, considering that we're only talking about cells and cells can't see one another, looks hypergamy just isn't a factor at this point. However, that can be discussed in later videos. It should also be noted that hypergamy under this situation is caused by the fact that male cells are cheap and plentiful and abundant. You can produce a ton of them for, with little mass expenditure, but females, they have to take a long time to fully develop. Therefore, hypergamy is enabled by the fact that there's a massive skew in sex ratio. In most species, that isn't the case, and we'll discuss why that is in later videos. However, we observe that this is the case in certain species, such as mallards, and other species of duck for that matter. The reason why this occurs is because ducks practice seasonal monogamy. Males do not guard or protect the nest or the females. Their bright coloration is merely a beacon for predators. As a result, females often end up getting killed defending their nests. The bottom 5 to 20% of males end up getting left out. The males who are left out then start forming gangs in which they forcibly copulate with females. Hypergamy as a result of gender skew can also be observed in humans. For example, in modern-day China and India, the sex ratio is skewed, so males significantly outnumber females. And in these countries, we observe that the bottom 5% of males are left incels simply because there aren't enough females to go around. Now, there are other points in human history in which we observe reverse hypergamy because a large number of males died off as a result of war. This happened in the Soviet Union following World War II, where men on the front lines were decimated by the Nazi invasion. And we observe that males tended to marry up as opposed to the other way around. This situation likely occurred repetitively throughout history and has certain evolutionary implications, such as a less than ideal fat ratio and distribution. The development of breasts in most mammals typically occurs after pregnancy. However, in human women, their breasts develop at the start of puberty. Being a bipedal species, the presence of breasts are rather inconvenient for women, as they make the female body front-heavy. This puts significant strain on the spine and can make activities such as running and walking more difficult for women, hence why female runners tend to be flat-chested. Finally, the face and body of the adult human female tends to be a lot more gracile and childlike. Henceforth, women have smaller and more youthful-looking bodies. Thanks for watching. Be sure to like, share, comment, and subscribe, and I'll see you in a future video.